Okay, this is number 8 from the first kinematic equation AP worksheet. This is a runner hopes to complete the 1,000-meter run in less than 30 minutes. After exactly 27 minutes, there are still 1,100 meters to go. The runner must then accelerate at 0.12 meters per second squared for how many seconds in order to achieve a time of exactly 30 minutes? So we have 3 parts of this. Oops. Part 1 is when the first part of the race. So for part 1, we know she goes delta x is 890 meter or 8,900 meters, and her time for that is 27 minutes, or 1,620 seconds. So part 2 is when the runner is going to be accelerating at this rate to some speed. So we know A for that equals 0.12 meters per second squared. And that's all we really know about that part. We'll know the initial velocity. We can find that from part 1. And then part 3. Part 3 is when she moves at a constant velocity. So the velocity for that part is going to be the final velocity from part 2. So we'll be able to find that eventually. I don't know that we need it. Alright, so we're looking for how many seconds does she have to accelerate for to achieve a time of exactly 30 minutes. So that's what we're really trying to find, the time for part 2. We'll call that T2. Okay, the first thing we're going to find, assuming that she ran a constant velocity for the first 27 minutes, so we're going to use those two things, the delta x and t, to find our v. So it's going to be v equals delta x over t. So 8,900 divided by 1620 gives us a velocity of 5.49 meters per second for the first part. Then for the second, that is our initial velocity for this part. Alright, we still don't have enough information to get very far, but we're done with part 1 now. Other thing we want to look at is the combination of 2 and 3. So 2 and 3, kind of the totals for that. So for 2 and 3, we know T2, which is what we're looking for, plus T3 equals 3 minutes. So we have 27 minus 30, so 180 seconds is what I'm going to write down here. And we also know that delta x for part 2 plus delta x for part 3 equals 1,100 meters. So we're going to use those two to figure out what T2 is ultimately. Alright, so let's set, we're going to use, you're usually better off using the delta x equation to solve for it. So for delta x2, so we're going to start with that. Delta x2 is going to be equal to VO times T2 plus 1/2 A times T2 squared. That's delta x2, and we just use one of our kinematic equations, and that's delta x equals VOT plus 1/2 AT squared. And we're going to add to that delta x2. This is constant velocity, so the equation we're going to end up using is just v equals delta x over t. We rearrange that, and we get delta x equals v times t. So we're going to say v, and I'm just going to call that v as the average velocity for part 2 since it's constant, and it's equal to vf from part 1. So v times t3, and the whole thing equals 1,100 meters. So now let's substitute some of the things we know in. We know our original velocity is 5.49. That's supposed to be a parenthesis times t2 plus, I'm just going to say 1/2 times 0.12 is 0.06, 0.06, and that's erase that, make it look a little nicer. 0.06, that's still not very nice 6, but that's okay, times t sub 2 quantity squared, plus, we don't know what this v is, but we can use an equation to find vf. So we know that vf from part 2 is equal to vo from part 2 times a times t2. So I'm going to write this out as vo plus at, and then times t3 equals 1100 meters. Going to do a little bit more simple. This is T2 here. Do a little bit more simplifying here. I'm going to, this is still 5.49 T2 plus 0.06 T2 quantity squared plus VO is 5.49 plus 0.12 times T2. And for T3, I'm going to say T3 is 180 minus T2. That equals 1100 meters. I'm going to let you guys do the algebra for that because I'm going to run out of space here. And when you solve this out, so you do some algebraic magic here, you get negative 0.06 T2 quantity squared plus 21.6 T2, that's a terrible 2, minus 111.8 equals 0, and you get T2 equals 5.2 seconds. Hopefully that helps you out. And when you solve this out, so you do some